These notes are about the special groups on the periodic table. Your learning target is, I can identify which special groups elements are in. What are periods? Periods are horizontal rows on the periodic table. There are 7 periods. Elements in the same period have the same number of energy levels. So you can see each color in our diagram is a different period. So we've got 1, 2, 3, 4, 5, 6, 7, and they all go across your periodic table. What are groups? Groups are vertical columns. Elements in the same group have very similar physical and chemical properties. So we have 18 groups here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, why are some colored and some not? We use some more than others. The ones that are colored are the ones we're going to refer to more often. And our groups go downward, so we can see that everything in the same column is the same color. So we have some examples we can look at. So if we were to find the element sodium, so if we find sodium on the periodic table, we can find sodium right here. All right, so what period is it in? Remember, that means row. So how many rows is it? So 1, 2, 3. It's in row 3. And what column is it in? What group? It's in group 1. So sodium is in period 3, group 1. Let's take a look for another one. What about Se? Try and find Se on the periodic table. Have you located Se? Se is over on the right-hand side. All right, so what period is it in? Remember, that's the row, so let's count how many rows down it is. 1, 2, 3, 4. So it's in period 4. And what group is it in? It is in group 16. So it was in period 4, group 16. And let's do one last one. Can you find aluminum on the periodic table? Have you found aluminum? Aluminum is located right here. So what period is it in? It's in 1, 2, 3. So it's in period 3. And what group number? Remember, group means column. So it is in group 13. So aluminum was in period 3, group 13. So now we have our special groups. Certain columns have certain names to identify them. So what are alkali metals? Alkali metals are group 1 because it's the first column. They are your most reactive of all metals. Because they're so reactive, they are not found in elemental form in nature. They are soft, bendable, shiny, and have a low melting point. Let's see some examples of these metals.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes! Wow. That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
Okay, and I have to point out in the second video, it is not totally accurate. They would have needed to use more of the element than what they were saying in order to get that level of explosion that they got. Group 2. What are the alkaline earth metals? These are still fairly reactive, but they are less reactive than the alkaline metals. They are found in compounds in the Earth's crust. They have high melting points and a low density. What are transition metals? Transition metals are in the middle of the table. They are less reactive than other metals. They are bendable, formed colored compounds, and have high melting points. What are inner transition / rare earth metals? They are rare, as the name says. They usually appear silver or gray. Many are synthesized, meaning they are created by humans and not found naturally in nature. And they are unstable, so they decompose into other elements. They each have their own special name. So the purple are called lanthanoids, and the yellow are called actinides. What are halogens? Halogens are group 17, if you remember which group that was. They are the most reactive of all elements. They are poisonous. They can be found in acids, hydrochloric acid, hydrofluoric acid. Might be a few that sound familiar to you. And they have low melting points. And then we have group 18, the noble gases. They are unreactive because they are stable. They are typically colorless, odorless, and non-flammable.